All right, so the functional relationships, there's actually a document in the lab manual. So if you go to labs, at the top there's lab manual, and you click on one of those, and there's one of the documents that's called functional relationships. What are the chances I have? Copy of this. Yeah. So you got functional relationships theory and functional relationships examples. So ultimately, you're going to end up with I guess the first one you had circumference versus diameter. And what you wanted to see is, were they directly proportional to each other? And the other one was, I guess, position, and you were looking at 1/2 AT squared, like something like that. As long as the slope of your incline stayed constant, acceleration should be constant in theory. And so you're basically, these are your variables, the distance that it was rolled and the time. Now, the trouble with writing it like this is that the distance was what you set and time was what you measured from that. You weren't saying, how far does it go in 2 seconds? You were saying, how long does it take to go 1/2 meter or whatever the distance was. So you would want to rewrite this in so that the dependent variable is basically isolated. So t squared is equal to 2x over a. In other words, you're looking at the relationship between those two variables. So is t squared proportional to x? Or in the case of the pre-lab, ultimately you want to set it up so that the analysis is easy. So if I had, let's see, something that I can think of just math problems right now instead of physics problems. Oh, ideal gas law. If I held temperature constant, and these are constants depending upon the amount of material I have, pressure and volume should be inversely proportional to each other. If I set the volume and then measure the pressure, so I set the volume, I measure the pressure, what is the independent variable?
T. Or
T would be a constant in this particular case.
that be volume? Oh.
Yes. The thing that I set is the, I think I asked for independent. The thing I set is independent, which seems sort of odd because we call it independent, but it depends upon me. It's the fact that it doesn't depend upon the pressure. So pressure is what we're measuring. Pressure is dependent upon volume. So I would want to rewrite this for pressure is equal to whatever that is, because all those are set in RT over V. Now, if I just plotted this straight up pressure versus volume, I would get hyperbola. Does that support this relationship? It's tough to tell. I mean, yeah, it's going to look something like that, but maybe it should actually look like that instead. I mean, how big of a curve is it? So it's a lot more difficult to do that analysis. It is possible, but there's a simpler way. If I look at pressure is equal to this, what ultimately is a constant for us in this problem, times 1 over V, and I look at those variables. I plot P versus the reciprocal of the volume. Now what should my graph look like? Nope. Parabola, this would be dependent upon that squared.
Exponential.
Pardon?
Exponential.
No, there's no exponent there.
Should have a positive slope, right?
Yep, I would hope so. Unless you can figure out some way of getting negative number of molecules or moles or negative temperature, which some theorists play some gymnastics and manage to do. But.
Could you repeat the question again, please?
The question is, if I plot pressure versus 1 over the volume, what would my graph look like?
A reciprocal?
Nope. So let's run through a plug and chug. So if I have xy is equal to 2, let's make it even simpler than that, 1. So y is equal to 1 times 1 over x. So x, let's go with 1, 2, 3, 4. 1 over x, which is what I'm plotting, would be 1/2, 1/3. Decimal probably makes more sense here. 0.5, 0.3, 0.25, 0.2, 0.16 repeating. And y should be 1 times that. So if I plot that set of coordinates, what would it look like? Yeah. And that's the whole point of what we're doing right here, is to try to set it up so that we can plot and get a straight line. Ideally, if I plotted P versus 1 over V, it should be a straight line going through the origin. That's slightly misleading. Questions before I talk about why that is slightly misleading? All right, so first off, again, delaying the why it's misleading. Why is this so much easier to analyze than this? Possibly.
Is it because you don't have to calculate the slope?
Why?
It's just a straight line, right?
In algebra, when you took algebra, you could just look at data points and go, oh, there's the slope. You said you didn't have to calculate the slope. I was wondering how you got the slope without calculating.
I got to pick up on my question all the way through on my answer.
I think you're close. I think you're just a couple words off. Riley, you look like you were about to. Oh, no, this is Germany. How do you find the slope of a line?
Rise over run.
Okay. How do you find the slope of hyperbola? Pardon?
Look at the equation.
Equal to some constant.
You calculate the area under the curve, or you do like a tangent line at a certain point?
For the slope, you do the tangent line. In math, what is that called? Is anyone here had some calculus?
Derivative.
Yeah, it's a derivative. So if I want to find the slope is not constant, so I can find the slope here by taking a derivative and finding the slope of the tangent line, or if I'm doing it manually, I would draw a line very carefully that's tangent to the curve and then find the slope of that line using rise over run. First, over here, I can take any 2 points and do rise over run. But the nitpick was that you still do some calculations, it's just a whole lot easier. Especially if you let the computer do the work for you. Questions before, again, I'm about to get to why it's misleading what I said earlier. If I plotted those data points, would it look like a line? I heard a yes. Everyone in agreement? Everyone got support that? Anyone want to disagree with that? Besides me? This is 1.5, 1.75. Let's assume I've drawn this correctly. All right, let's plot. I got the point 1, 1. I'm not going for the fact that I can't draw straight lines and I can't space it out evenly. That's not the point I'm going for here. Somewhere around there. That. Somewhere around there. Try to make it look at least a little bit better. Have I plotted the points? Close enough? Is that a line?
Yes.
All right, for those of you who aren't nodding, I assume you're expecting either you're shy or you're expecting me to say it's not a line. What is a line?
Straight point to point.
Straight point to point.
I don't know how to describe that.
A set of connected points.
Okay. Are these connected points? Is it a line?
No.
How many points are in a line?
At least two.
Sorry?
At least two.
Ooh. 2 points define a line, but they don't make the line. Yes. It's the trend line. In data, what we do is we plot data points, and then we come up with our best guess, or an educated guess, over what, if we did every single possibility, what it would look like. That's the trend line. So if I plot these points and did a trend line, yes, the trend line actually should go through the origin. But we don't plot every single one of those points. We just plot enough of them to get to enough point where we're going, yeah, I think if we did all of them, it would look like that. And then we draw a line. So that's the potentially misleading part. It's that the trend line should go through the origin. Anyway, it's a, one might say, a pedantic argument, but, and something just to mull over the weekend. Are those the same number, or are they just two numbers with the same value? Anyway, let you think about that. Any questions? When Thanksgiving rolls around and you're with family or friends, ask them that. And then talk about physics. Other questions? I guess one question. Lisa, did I actually answer your original question?
I believe so.
Okay.
So the dependent number is usually by itself, well, first, and then the independent number is later. When you
That's the form you probably want to put it in, because what's the classic formula for a line?
MX plus B. Y equals.
Oh, thank you. Except when I do it, I tend not to use m because we use m for mass, we use m for meter, so you know, slope x plus b. It's the slope-intercept form. And since the dependent variable should be on the vertical axis, our traditional y, that's why you want to get it in that form, so that whatever's in front of our independent variable is the slope. I believe it makes life a little bit easier.
So you just figure out the constant and then, okay.
Yeah.
That's
All right, so other questions right now? Okay. No questions on master set 3? Let's talk about projectile motion. First off, in order to do projectile motion, we really need to have the cake formulas down. So what are the constant acceleration formulas? And by the way, I've graded some of the master set 2s. you only use the constant acceleration formulas when acceleration is constant. If acceleration changes, please don't use that formula. Or these formulas. Some of you on that long, the problem that had part A through U, some of you were applying those formulas for like displacement for the entire trip. It doesn't work because acceleration changes halfway through the problem. All right, so what are the cake formulas? Can anyone do it without looking at notes? All right, then we'll go for notes. What do we got?
Final volume equals initial volume.
Ooh, try again. I'll write down the letters.
Final velocity.
There we go.
Equals initial velocity plus acceleration times time.
All right, there's one.
Final velocity squared equals initial velocity plus 2 times acceleration times the change in
X, S, R, whatever you happen to be using. What kind of multiplication goes on there? Yeah. All right, so let's take a moment to look at this bit right here. She said velocity, final velocity squared, but I don't have a vector symbol over it. Isn't it final speed squared? Or does it matter?
So would it be fun? It would be final speed, wouldn't it?
That's the way the formula, that's the way I wrote the formula at least. Should I put a vector symbol over the V? What does it mean when you square a vector?
It becomes a scalar product.
Yeah. Typically, I have some vector that, when you're squaring it, you're basically doing a dot product with itself. And so that would be the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. Well, any vector, what's the angle between any vector and itself?
0.
Yeah. So this becomes 1, and you're just left with a squared. So technically the formula is speed squared. However, if you say velocity squared, it's supposed to be understood that when you square a vector, you're doing a scalar product with itself, as opposed to a cross product. All right. So those are the two VF formulas. What about the other two? The two delta X or delta S?
Initial volume times time.
velocity.
That's what I said.
It's like later on, we're going to be dealing with normal force, but the most common mistake is to call it the natural force. People remember it begins with the letter N, but it's normal later on. Anyway, one more time, with feeling.
Initial velocity
Okay,
times time
all right.
plus half acceleration times time squared.
Yep. And lastly,
Initial velocity plus final velocity divide that by 2 times time.
this bit right here is just average velocity. Again, the assumption here is acceleration is constant. I'm going to run and get a prop. I'll let you sort of contemplate the 3 and 3 question, and I'll be back. And if someone would be kind enough to remind me to start this up again.
It's calculus 2 for 3D.
No, but calc 2 is way harder than calculus 1.
Intro versus calc 2 is advanced. Calc 3 is calc 2 is advanced.
That's what I've heard would be an issue there.
Yeah, I took it for like
So-
2 years and I dropped out of the class.
All right, so what we have here is a projectile launcher. Horizontal is fine for what we need to do right now. All right, so I'm going to have a ball slipped onto here. So basically when you flip the switch, there's a spring inside here which is going to take this rod and shoot the rod that way. When the rod gets shot that way, this ball is not going to move a whole lot. It's not going to be pulled that way. It should be slick enough inside there that, and this is going to move so quickly that it should just basically fall straight down. Close enough. Meanwhile, I have another ball over here which is going to get hit by the plunger, and so that this ball is going to get shot outwards. So this ball will be shot outwards about the exact same time that this thing starts to fall. And so the question is, which will hit the ground first? So let's see if physics by democracy works. We've got the one that falls straight down, the one that gets launched. We'll call this A and B. C, a tie, and D, neither. It's the floor at all. That last one I'm curious about if that would ever happen. But anyway, well, as quantum physics teaches us, pretty much all things are possible, not necessarily probable.
I think it's B.
All right, let's just go for vote A. Who says A?
I'm missing. What's the?
Which is going to hit the ground first? So A is this one that falls pretty much straight down is going to hit first. B is this one will hit first, the one that gets shot that way. C is they hit about the same time, and D, something mysterious happens and they disappear. Or explode. All right, so A, the one that falls straight down, going to hit first. We got 3. B, the one projected will